Welcome to Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and I'm here with my co-host Gary LaRude. In this episode, we're going to continue our coverage of the April amplifier and oscillator issue. As a reminder, the cover story discusses how RF SOI can save billions of dollars in the network infrastructure for 5G millimeter wave applications with highly efficient PAs. So take a look at that if you haven't already seen it. So we're going to go ahead and take a look at the products because we took a look at the technical features last time. What do we have for products, Gary?
Well, we have two product features this month. First one from RFHIC is a 6 kilowatt, 2.4 gigahertz solid state microwave generator. This is intended to replace tube amplifiers in applications like semiconductor processing equipment or industrial food processing. So you can think of this as a very big microwave oven. They actually combine four 1.6 kilowatt PAs, and they use their own 200 watt GaN transistors, so it's all solid state. They have a power supply with 6 rectifier modules, and that gives our second product feature is from Searlinks. It's an oven-controlled quartz oscillator, which is something you could use as the master oscillator in a system. They have options from 10 to 40 megahertz. This one has very low power consumption. They say it's 10 times lower than comparable oscillators, and it's very small and lightweight. The one way they get this, they say, is by having an embedded ASIC in the oven and oscillator, so it can control the oscillator functions and manage the oven. So it's a pretty cool product. So how about tech briefs, Pat?
Yeah, so for tech briefs, we had two. One was a slotted waveguide antenna array from Aerovent, and that's formerly Sage Millimeter, and that covers WR90 to WR10. And then we also had high reliability precision thin film resistors from Susumu, Germany. So those are two to take a look at. And we did have a very special guest join us remotely today, Thomas Emanuelson. He's a CTO at Gapwaves. He joined us to discuss their waveguide technology and some of the markets they're addressing with that unique technology. So let's take a look at a clip from that now.
Tell us a little bit about the Gapwaves technology, the Gapwave waveguide, what problems it solves and what applications are well suited for it.
Yeah, sure. So the gap waveguides technology is, as I said, it's basically long time research based on hard and soft surfaces, and it's a way of actually mitigating the problem of building waveguides, connecting the waveguide walls to the waveguide lid. And as anyone that has been doing that as a millimeter wave designer, you know the hassle of connecting waveguide walls to the lid. And that is what you actually avoid when using this what we usually daily call the pin structure. So you can build waveguides without connecting physically the waveguide walls to the lid, avoiding their glue, silver epoxy, bracing, welding, or 1,000 screws or something like that. So you can build multi-layer waveguides instead, easily by doing this. The applications that we're actually looking into is basically phased array antennas is the first thing that we're doing, and we are targeting, for example, right now, 5G systems where you need a phased array antenna at anywhere from KU band up. We are currently doing development at 28 gigahertz and 24 gigahertz, building the low loss antennas in waveguide technology, using the gap waveguide as a connection mean for the multi-layer structures, and also to introduce the PCB with the components into the antenna structure. The other thing that we are doing is automotive radar, and in the light of having self-driving cars and so on, it's very essential to have a good sensor, and going up in frequency to between 76 and 81 gigahertz is a very good way to use waveguides. So you get rid of a lot of losses and can do a very efficient antenna in that way. Typically for an automotive radar, you say that you double the target area that you're looking at, and you can play around with the waveguide ports and the antenna to do different pattern shaping and so on. It's a very efficient antenna. For the 5G, typical antenna has an efficiency of, the antenna as such has an efficiency of around 90%, compared to a PCB type antenna that is most likely around 50%.
Gapwaves is really doing some neat things with that technology, so it'll be interesting to keep following them in the market. So turning to the news, according to Strategy Analytics, the market for mobile RF front-end components was flat in 2018 and 2019, and they expect it to remain flat, maybe even declining because of COVID-19 for 2020. So analyst Chris Taylor said that the overall changes to that market kind of hit Skyworks the hardest with a little bit of decline, and Qorvo and Broadcom were able to remain pretty flat, while Qualcomm picked up some wins in the 5G marketplace. And then there are also a number of new entrants, mostly from China, and they hit some of the lower end phones, so took away a little bit of market share there. So interesting to follow that, and hopefully we'll get a nice kick up at the end of this year if everything gets back to work. So also in the A&D news side, Raytheon Technologies Corporation announced a successful completion of the merger between equals, Raytheon Company and United Technologies Corporation. And that's after the completion of the United Technologies previously announced spin-offs of Carrier and Otis businesses. So Raytheon Technologies is now one of the biggest aerospace and defense companies in the world. They have almost 74 billion in sales and close to 200,000 employees, so quite the big enterprise. And they'll still be headquarters in Waltham, Mass, where Raytheon Company previously was. So what did you see in the news, Gary?
Well, a couple items. The FCC is set to vote on April 23rd to add 1.2 gigahertz of spectrum at 6 gigahertz for unlicensed use. This would cover specifically 5.925 to 7.125 gigahertz. They're actually proposing two use cases, so they protect the current licensed users for point-to-point and Earth-to-space links. The first would be for indoor use. Users can use the entire frequency band, and they just have to use lower power. So for an access point, that's 24 dBm conducted power. For outdoor applications, they can only use Uni 5 and Uni 7 subbands, and the conducted power there is limited to 30 dBm. And they have to use an automatic frequency control system so they know who's got the licenses in that particular band, and they avoid interference. Also for satellite operation, to avoid interference there, they have to make sure the antenna is not pointing in a direction that could interfere with the geo. And then one other thing, obviously the FCC just recently completed the Auction 103, which pushed 5G spectrum up to 47 gigahertz in the US. Well, the 3GPP is studying actually using spectrum above 50 gigahertz. I saw this on the 3G, 4G blog, and it's interesting. There's a new report or an updated report that talks about use cases from 52.6 up to 116 gigahertz. So if folks are interested in reading about that, you can go to the 3GPP website and look for the technical report 38.807. And turning to events, obviously there's a lot of uncertainty about in-person events this year, but we're busy planning our EDICon online event, which will be the second year in a row for that. So mark your calendars. It will be every Tuesday in October. And Tuesdays will be organized by topic. So the first is 5G, IoT, and automotive. The second, PCB and interconnects. Then we go to signal integrity and power integrity, and wrap up the month with radar and antennas. And you can find more information at www.edicononline.com. And that brings us to the close of another episode. We want to thank our sponsors, RFMW, a pure play RF microwave distributor, and Wireless Telecom Group. They're the parent of Booten, CommAgility, Holsworth, Microlab, and Noisecom. So we end this episode with our wish that you and your family are well, you're minimizing possible exposure to the coronavirus. And for those of you who have lost a job, we're hoping we'll get through this time quickly so the economy can begin to recover and people can get back to work. Thanks for joining us.